Have you ever stared at a truly massive undertaking? Maybe it's building a new high-rise, launching an ambitious product, or even just tackling a major home renovation and thought, how on earth do they even begin to organize all of that?
Yeah, it's mind-boggling, right?
The sheer scale of coordination, the countless moving parts, those relentless deadlines, and the ever-present budgets. I mean, it can feel like trying to conduct a symphony orchestra where every single musician is a solo artist and the sheet music keeps changing.
That's a great analogy, actually. It really captures the complexity.
Well, today, we're taking a deep dive into precisely that challenge, the intricate, often demanding, but incredibly rewarding world of professional project management, especially as it applies, to the construction industry.
Hmm.
We're going to pull back the curtain on how these huge endeavors are broken down, managed, and hopefully brought to successful completion.
And our sources provide a truly fantastic roadmap for this. They guide us from the very definition of a project right through the nuanced dance of stakeholders and deadlines.
So this deep dive is kind of a shortcut.
Exactly. It's designed to be your shortcut to understanding the fundamental concepts, the practical frameworks, and the essential tools that underpin successful project delivery. Our mission is to extract those vital nuggets that will help you understand not just the what, but the why and the how behind getting big things done no matter your field.
Right.
Because at its core, managing a construction project shares many universal principles with managing, well, any complex task, really.
Okay, let's unpack this. We're starting at the absolute beginning with a foundational question. What exactly is a project in the professional sense of the foundation? What exactly is a project? So we use the word project all the time in everyday conversation, right? But in the professional realm, it carries a very specific meaning. It's not just any task you decide to tackle.
Not at all.
Our sources highlight several core characteristics that truly define it. First and foremost, a project is a task with a definite start and end point. It has a given timeline, a clear beginning, and a clear finish. It's not an open-ended, ongoing operation.
And that temporary nature is absolutely critical. Unlike routine operations, which are, continuous and designed to produce the same output repeatedly.
Like running a factory assembly line.
Exactly. A project is a specific, time-bound endeavor designed to create a unique product, service, or result, something new.
Okay.
And this distinction fundamentally changes how you approach its management.
No.
You need a different set of tools and methodologies than, say, managing that continuous factory output. It's about creating something new, not simply maintaining the old.
And it's not just about time, is it? It's also about boundaries. A project comes with defined and limited resources.
Right, finite resources.
Think about it. A specific budget you have to stick to, a certain number of personnel, a set amount of materials. You can't just keep pouring resources into it indefinitely.
No, the constraints are real.
Plus, it utilizes special tools and techniques specifically for project management. This isn't just about winging it, hoping for the best.
Definitely not. There's a discipline to it.
And almost always, it requires a diverse team, often stretching across different departments or even different companies, all working towards that singular, unique goal. It really feels like an organized sprint rather than, say, a continuous marathon.
That's a perfect way to put it. What's truly fascinating here is how clearly a project is defined by that temporary nature and its unique output. It's not just a task, it's a specific one-time endeavor that stands apart from the day-to-day operations.
Okay.
And this uniqueness introduces a level of inherent uncertainty and, well, complexity that demands careful planning and a structured approach, which is exactly why project management methodologies exist in the first place, to handle that uniqueness.
That brings us perfectly to the next logical step. If a project has a clear start and end, it must have a journey, right? A life cycle.
A definite path.
And in the world of project management, that journey is typically broken down into 5 distinct phases. Think of it as a methodical roadmap for bringing that unique vision to life, making sure nothing important gets overlooked. B, the 5 phases of project management. A life cycle approach. Let's start right at the beginning with the very first step, the initiation phase.
The kickoff, so to speak.
Exactly, but it's far more than just a kickoff meeting. It's where the decision-making team asks a really crucial question. Our source material phrases it wonderfully in Filipino, kaya ba ni, which translates roughly to, can it be done?
Right. Is this even feasible?
This phase is about rigorously assessing if the project is realistically achievable within the given constraints and time frame. Is it even viable before you pour money and time into it?
It truly is the big gonna-go decision point. You're not just greenlighting an idea, you're confirming its fundamental feasibility.
Okay.
If you skip or rush this phase, you risk investing significant resources into something that's, well, fundamentally unfeasible, which inevitably leads to problems, wasted effort, and huge costs down the line.
Yeah, makes sense.
It's about establishing that initial business case and a clear vision before committing fully.
So once you've confidently decided it can be done, you move into what is arguably the most critical phase, planning.
Ah, yes, the heavy lifting.
This is where you meticulously prioritize everything, calculate your budget, and schedule down to the hopefully finest detail and determine precisely what resources are needed. The core questions here are, kaya ba sa budget? Is it within budget?
Yeah.
And kaya ba mahuman with the resources we have? Can it be completed with available resources?
Crucial question.
This is where all the real groundwork is laid, the foundation for everything else.
This phase truly lays the foundation for success, or indeed for potential failure later on. Poor planning almost inevitably leads to issues, delays, and cost overruns in the later phases.
You hear about that all the time.
Absolutely. It's about meticulously mapping out every single step, anticipating potential roadblocks, allocating resources strategically, and defining quality standards. You're essentially trying to foresee the entire journey before you even take the first physical step. It's a proactive approach that saves immense headaches later.
With a rock-solid plan in hand, hopefully rock solid, we shift to the execution phase.
The doing part.
This is the doing part, yeah. The exciting stage where all those carefully laid plans come to life. Roles are delegated, positions are assigned, and the actual work begins. You're asking practical questions like, Kinsai part say design team? Who is part of the design team? And Kinsai mo manage? Who will manage this particular aspect? This is where the real building, or doing, starts.
This is truly where the rubber meets the road. All the previous strategic decisions translate into concrete actions.
Right.
Effective execution relies heavily on clear communication, efficient delegation, and strong, adaptable leadership, ensuring that everyone knows their role and how it contributes to the overall project goal. It's about orchestrating all those moving parts we talked about at the top of the show.
Okay, but as the work is being executed, it's absolutely not a set-it-and-forget-it situation.
Oh, definitely not. You wish.
That's where the monitoring control phase comes in. This runs concurrently, side by side, with execution.
It has to.
Its purpose is to constantly track progress, compare actual performance against the plan, manage any changes that inevitably arise,
Because they always do.
and ensure that everything stays on track. The core question is, how is the overall project flowing from start to finish compared to our initial vision? You're essentially holding up your progress to your baseline plan and making necessary adjustments, keeping it honest.
This continuous oversight is paramount. It allows project managers to identify any deviations from the plan early, take corrective actions before they become major problems, and adapt to unforeseen circumstances without completely derailing the entire project.
So course correction.
Exactly. It's about maintaining control over the project's direction and ensuring that it continues to align with a defined scope, budget, and schedule. Without effective monitoring and control, even the best-laid plans can quickly unravel, leaving you with, well, chaos.
Finally, after all that, we reach the closing phase.
The wrap-up.
This isn't just about finishing the work and saying, phew, we're done. Though there's probably some of that too.
Oh, definitely a sigh of relief, usually.
It's the formal completion of the project. This includes a proper handover to the client or end user, a thorough evaluation of whether the project was actually a success,
Based on the initial goals.
and, crucially, identifying lessons learned for future endeavors. What went right, what went wrong.
You have to capture that knowledge.
It's about wrapping everything up formally, archiving documents, releasing resources, and reflecting on the entire journey.
It's vital for continuous improvement.
So, what does this all mean for someone just starting to think about managing a project? It's about understanding this complete journey, this life cycle, not just jumping straight to the doing part, the execution. Each phase builds on the last, and skipping or shortchanging any one of them can have massive ripple effects across the entire project. It's a structured approach designed to bring order to potential chaos, to give you a roadmap through even the most complex undertaking. 2. The project manager's toolkit, process groups, and knowledge areas. Now you might be thinking, okay, that's a nice linear path, those 5 phases, but how do I actually manage all those intricate details within each of those phases?
Right, how do you operationalize it?
Well, project management, especially in complex fields like construction, isn't just a simple linear process. It's supported by a robust organizational framework. Our sources lay out a structure of process groups and knowledge areas, which essentially define what you need to do and what you need to know.
It's like a matrix, almost.
Let's look at the 5 process groups first. We have initiation, planning, execution, monitor and control, and finally, closing.
Those sound familiar. They map directly to the phases we just discussed.
They do. But the framework counts the processes within each. And what immediately stands out is the sheer emphasis on planning. Our sources say there are 24 processes just in planning, compared to only 2 in initiation, 10 in execution, 12 in monitor and control, and just 1 in closing.
Wow, 24 in planning. That's huge.
It really is. Almost half of all project management processes are dedicated to this phase. This isn't just busy work, it's a proactive strategy.
Yep.
The insight here is that time spent planning isn't lost time. It's a crucial investment that drastically reduces chaos, costly mistakes, and unwelcome surprises down the line. Much like architects meticulously blueprinting every single detail before a single brick is laid.
Exactly. These process groups provide a universal, systematic roadmap for how you move through a project. But to truly understand the depth of that planning, you need to look at the 10 knowledge areas.
Okay.
These are distinct domains of expertise that a project manager needs to master and integrate across all those process groups. Think of them as a comprehensive checklist for every single aspect of your project. You need to know about all these things.
So what are they?
Okay, the 10 knowledge areas are 1. Integration management. This is the big one, kind of the glue, pulling everything together, coordinating all the other areas.
The conductor of the orchestra.
Precisely. 2. Scope management. Defining precisely what is and isn't included in your project, setting those boundaries clearly. 3. Schedule management. Ensuring you hit those crucial deadlines. Managing the timeline. 4. Cost management. Keeping a tight rein on the budget, the money aspect. 5. Project quality management. Making sure the final product or service meets all the required standards and expectations.
Not just getting it done, but getting it done right.
Exactly. 6. Resource management. Handling all your people, materials, and equipment needs efficiently. 7. Communication management. Because clear and timely information flow is the absolute lifeblood of any project.
Yeah, poor communication sinks projects.
It really does. 8. Risk management. Identifying potential problems, uncertainties, things that could go wrong in planning for them. 9. Procurement management. Dealing with external suppliers, vendors, contracts, buying things. 10. And finally, stakeholder management. Engaging effectively with everyone who has a vested interest in the project's success, keeping everyone informed and, ideally, happy.
You know, what's so powerful about this framework, looking at both the groups and the areas, is how it highlights the interconnectedness.
It's not silos.
It's not about tackling each of these in isolation. If we connect this to the bigger picture, these process groups and knowledge areas provide a universal language for project managers. It's a standard, systematic way to ensure no critical aspect is overlooked.
Right.
When you're in that planning phase, with its 24 processes, you're simultaneously planning scope, cost, resources, quality, and how you'll manage risks and communicate.
All at once, integrated.
This framework forces a holistic approach, where a change in one area like schedule is understood to potentially impact others, like cost or scope. It fosters truly integrated decision-making.
It does. It's this systematic organization that transforms a collection of tasks into a professionally managed project. It gives you structure. 3. Navigating the landscape. Core constraints and challenges.
Now, for anyone who's ever tried to build something or manage a complex task, you know it's rarely a smooth ride. There are always trade-offs, pressures, unexpected issues popping up.
Always. Murphy's Law loves projects.
And at the heart of this challenge lies what's often called the triple constraint.
Ah, the classic triangle.
Think of it like a three-legged stool. You have scope, cost, and time. The idea is that a project scope, what you're delivering, can be completed for a reasonable cost and in a reasonable time.
In theory.
The key insight, though, is their absolute interdependence. They're locked together. If you pull on one thread, say, you suddenly need to finish much faster, shorten the time.
The deadline gets pulled in.
Right. Then the other two, your cost, and potentially what you're actually building, the scope, have to shift. It's like a delicate balancing act.
You can't change one without affecting the others.
Exactly. There's no free lunch in project management. Accelerate the timeline, and you'll likely increase costs, or maybe have to reduce what you can deliver, cut some features.
Or sacrifice quality, which we'll get to. These 3 elements, scope, cost, and time actually form what we call the project baselines.
Baselines.
Yeah, these are the approved initial plans against which all project performance is measured throughout its life cycle, your starting point. The ideal scope, as envisioned, includes all the work needed to create the product with zero defects, zero waste, perfect safety. The ideal.
A perfect world scenario.
The perpetual challenge, of course, is maintaining that ideal or staying close to those baselines in the face of real-world pressures and unexpected changes.
But wait, there's another critical factor that often gets added to this equation, forming what some people call the quadruple constraint. That's quality, right? B, adding quality to the equation.
Indeed. Quality is often seen as central, influenced by the other three. Ultimately, a project scope accomplished for the right cost and in a reasonable time should create a product or service that satisfies stakeholder requirements. That is what we mean by quality.
So it's not just about hitting the numbers for time and cost.
No. The diagrams in our sources suggest that changes in one constraint will inevitably impact the others, and true project success involves finding that optimal balance point among these factors to ensure the desired quality is consistently met. It's not just about doing it fast and cheap, it's about doing it right for the specific requirements and expectations set out.
That makes sense. Balancing act is the right word. Which brings us to another undeniable truth of projects. Things change.
Always. Change is the only constant.
No matter how meticulously you plan, something unforeseen will pop up. A requirement changes. A material isn't available. Something unexpected happens on site. And that's where change control becomes absolutely crucial. C. Handling the inevitable. Change control.
Any change request, no matter how small it seems, must undergo a formal approval process. This isn't just bureaucracy for bureaucracy's sake. It's a vital protective mechanism for the project.
Right. It stops things from spiraling out of control.
Exactly. The outcome is typically a formal change order. This structured process prevents what we call scope creep.
Ugh, scope creep. The silent killer.
It can be, where additional work is unofficially added to a project, maybe through informal conversations or small requests that pile up.
Yeah, while you're at it, can you just...
Precisely. And that leads to uncontrolled budget overruns, schedule delays, and ultimately a project that veers wildly off course from the original plan.
So change control keeps things deliberate.
It ensures that every adjustment is deliberate, it's approved, and its impact on the triple constraint scope, time, cost, and quality is fully understood before you implement it. It's about maintaining control in a dynamic, changing environment.
Speaking of challenges, the construction industry is famously complex and, let's face it, fraught with potential pitfalls. Our sources list the top 5 challenges for construction project managers.
And it's no surprise what they are.
What's interesting is how directly these challenges relate back to that triple constraint and the need for robust planning we just discussed. Top 5 challenges for construction project managers. Okay, so these top challenges are: 1. Budget constraints always pressure on the money.
Number 1, usually.
2. Time management hitting those deadlines. 3. Unrealistic expectations from clients, stakeholders, maybe even a team itself.
That's a big one.
4. Hazard management dealing with safety and unforeseen risks on site. 5. And poorly defined objectives not being clear on what you're actually supposed to build or achieve.
It's fascinating how these challenges often expose weaknesses in those early planning phases we talked about.
How so?
Well, take, for instance, unrealistic expectations. That's often a failure to properly align scope, cost, or time right at the outset, in the planning phase. Someone promised something that wasn't really feasible based on the resources or time available.
Okay, yeah.
Similarly, budget constraints and time management issues are often direct descendants of not adequately defining and managing that triple constraint from the start.
Right.
Hazard management speaks directly to the need for a thorough risk planning, another key knowledge area, and poorly defined objectives. That's a fundamental failure in scope definition.
So it all circles back.
It really does. It all circles back to the importance of a systematic, proactive approach right from the very beginning. Good planning prevents so many of these downstream headaches. 4. Defining the what and the how. Scope and work breakdown.
All right, so we've established what a project is, its life cycle, the overarching framework, and the common challenges.
Yeah.
Now, how do you actually get down to defining the what exactly are we building or doing, and the how are we going to do it?
This is where the rubber really meets the road in planning.
This is where the project management plan, and specifically scope management, really shine, isn't it? A, the blueprint, project management plan and scope management.
Absolutely. The project management plan is essentially the comprehensive blueprint for the entire project. Think of it as the master document.
The single source of truth.
Ideally, yes. It's a living document that outlines all the project work and precisely how that work will be performed, managed, and controlled. Within that larger plan, we have plan scope management. This is the specific process of documenting how the project scope will be defined, validated, and controlled throughout the project.
So it's the plan for managing the plan's boundaries.
In a way, yes. It's crucial because, as we touched on with scope creep, clearly defining and controlling scope prevents major headaches and those unwelcome surprises later on.
And when we talk about scope definition itself, it's literally the work, and only the work, required to create the product, service, or result.
Emphasis on only the work.
Right. Our sources clarify this beautifully. It defines how meaning is work-oriented, focused on the activities, and what meaning it outlines the specific features and functions that characterize the service or product. It's about being incredibly specific about the boundaries of your project, drawing those lines in the sand early and clearly. B, components of a scope of work, SOW. Okay, so to put that scope definition into a practical, actionable document that you can share, you'll often create a scope of work, or SOW.
The SOW, yeah. Very common document.
This document typically includes several key things. A concise project overview, what's the context, the detailed project scope itself, explaining exactly what will be done, the specific project deliverables, the tangible things you'll produce, the outputs, and the overarching project schedule, key milestones, or deadlines.
It's the comprehensive statement of what needs to be delivered and the key conditions surrounding that delivery. Everyone involved should be able to read the SOW and understand what's expected. C, breaking it down. The work breakdown structure, WBS.
Okay, let's unpack this with a relatable example because scope can still feel a bit abstract. You can't build a house by just saying build a house, right? That's way too big.
Impossible to manage at that level.
You need to break that huge goal down into manageable pieces. And that's exactly what the work breakdown structure, or WBS, helps you do.
The WBS is fundamental.
It's a systematic and formal approach to defining all the work elements or work packages, the smaller chunks that make up the project. Think of it as creating a big, organized, hierarchical list of deliverables.
Like an organizational chart for the work itself.
Exactly. And that list will eventually determine all the individual activities or tasks needed to accomplish them. The preparation of the WBS is all about work determination, or work definition, figuring out in really granular detail what actually needs to be done.
The WBS is a cornerstone of effective planning. It decomposes the entire project work into smaller, more manageable components.
Which makes everything easier, presumably.
Oh, absolutely. It makes it much easier to estimate costs, assign responsibilities clearly, and schedule tasks accurately. Our sources give us a fantastic illustration using the example of construction of a house. 1. Deliverable-based WBS example. Construction of a house.
So, in a deliverable-based WBS, you break down the project by the actual things you're creating, the tangible outputs or components. So for construction of a house, your ultimate level 1. Project goal is just that, construction of a house. That's the big picture, the top of the hierarchy.
A final deliverable.
But then, at level 2, major deliverables control accounts, you start to see the breakdown into major components. The project is typically categorized into areas like internal, focusing on everything inside finishes, systems, foundation, dealing with the structural base, excavation, concrete, and external, covering the outside walls, roof, finishes.
These level 2 items are still pretty big, often managed as distinct chunks, sometimes called control accounts for tracking costs.
Right. And then at level 3, sub-deliverables work packages. Each of those major deliverables is further broken down into specific actionable components. These are the work packages, often with assigned responsibilities and budgets tied to them.
Exactly. So, for example, under internal, you might have electrical work, which would involve contracting an electrical specialist and have a specific budget allocated, say, $25,000 in the example. And plumbing, similarly managed by a plumbing contractor with its own budget, maybe $61,000.
And for foundation, you'd see things broken down like excavate, perhaps performed by a labor crew with a budget of $37,000,
Right.
and steel erection, maybe overseen by a general contractor superintendent with a budget of $11,000.
Mm-hmm.
And for external, your level 3 might include masonry work handled by a masonry contractor with a budget like $62,000, and building finishes like painting, detailing work for a painting contractor with a budget of, say, $21,300.
The purpose of this deliverable-based WBS is truly multifaceted. First, it explicitly defines the project scope by listing all the work required in a structured way. Nothing gets missed, hopefully.
Yeah, you can see everything laid out.
Second, it critically facilitates planning and estimation. Breaking work into these smaller, manageable work packages aids immensely in cost estimation, assigning responsibilities, and developing the schedule.
It's easier to estimate the cost of electrical than the whole internal chunk.
Precisely. And crucially, it enhances communication and accountability. It provides a clear visual representation for all stakeholders, contractors, team members, defining precisely who is responsible for delivering what. It's the ultimate demystifier of complex tasks. It makes it clear. 2. Phase-based WBS example for a house construction.
Now, that's one way to structure a WBS by deliverable, but you can also approach it in a phase-based way, can't you?
Absolutely.
Yeah.
This structures the work chronologically based on the major phases of the project lifecycle.
So for our house construction example, this would look maybe something like 1, design phase, and under that you'd have activities like obtaining permits, 1.1, and producing detailed drawings, 1.2.
The planning stage deliverables.
2. Next, maybe a procurement phase. Here you'd focus on sourcing and acquiring all necessary materials and maybe subcontractors for electrical, 2.1,
Yep.
plumbing, 2.2,
Oh.
and HVAC systems, 2.3.
Getting everything lined up.
3. Then comes the main construction phase, perhaps broken into interior work, 3.1, walls, flooring, etc., and exterior work, 3.2, the building envelope, roofing, finishes.
The actual building part.
4. After that, an inspections phase, with specific quality checks for things like masonry work, 4.1, and overall building finishes, 4.2, getting sign-offs,
Verifying quality.
5. And finally, the turnover phase, which involves a client walkthrough, 5.1, to review the completed house, and a formal closing, 5.2, for completion documents and handover.
This phase-based WBS provides a clear chronological roadmap. It ensures all critical steps and their sub-activities are accounted for in a logical sequence. It's about structuring the workflow in time, making sure you don't try to, install the carpets before the roof is on.
Right, order matters.
Hmm.
3. Work breakdown structure using CSI format. And for those specifically in construction, there's even a standardized way to create a WBS using the Construction Specification Institute, or a CSI format, right?
Yes, the CSI master format is widely used in North America, especially. It provides a standard organizational structure using numbered divisions and sections for construction specifications, drawings, and cost data.
So it's like a predefined structure everyone understands.
Exactly. When you see references to Division 1, general requirements, or Division 3, concrete, or Division 8, doors and windows, or Divisions 15 and 16 for mechanical and electrical, everyone in the industry knows exactly what area of work is being discussed.
Okay.
This really shows how a WBS isn't just an abstract management concept, it's a highly practical, often standardized tool in specific industries like construction. Using something like the CSI format ensures that everyone speaks the same language when defining work.
Which must be crucial.
Oh, absolutely crucial for complex construction projects. Miscommunication about a work package could lead to significant errors, delays, and very costly rework. It's about having a common dictionary, a standard index for all project participants. It can be shown graphically or just as a direct listing, like the UCI Uniform Construction Index Cost Analysis format mentioned. V, orchestrating the work. Scheduling, resources, cost, and quality.
So we figured out what needs to be done, broken it down with the WBS, but then comes the big question of when it will get done and how efficiently, and using what resources, and ensuring it meets quality standards.
Right. Now we need to put it all together, orchestrate it.
This is where we bring in the tools for orchestration, for truly conducting that complex project symphony we talked about earlier. A, visualizing time, scheduling tools.
A critical part of this orchestration involves meticulous scheduling. One powerful technique mentioned is precedence diagramming methods, or PDM. This isn't just a list of tasks, it's a graphical representation of all the work that needs to be performed, showing the flow of the project.
How things connect.
Exactly. It illustrates how work packages tie into other work packages, their order, their durations, and crucially, their dependencies. The key here are the relationships between tasks.
What kind of relationships?
Well, the most common is finish to start, FS. This means one task must finish before the next one can begin. Think about it. You can't start painting a wall, successor, until the plaster, predecessor, is completely dry and finished.
Makes sense.
There are others too, like finish to finish, FF. One task can't finish until another one finishes. Or start to start, SS. One task can't start until another one starts. And less commonly, start to finish, SF. One task can't finish until another one starts. But FS is the big one.
Okay. These diagrams sound pretty important then. They define the logic.
They do. And they help you find the project's critical path. That's the sequence of activities that have zero slack or float, meaning any delay in those specific activities will delay the entire project finish date.
Ah, the critical path. You hear that term a lot.
It's vital for focusing management attention. Then we have project schedule network diagrams. These are essentially system-wide drawings that show the entire project's work packages or activities and their dependencies from start to finish.
The big picture view of the flow?
Exactly. These diagrams are fantastic because they help identify tasks that can run simultaneously in parallel, which helps optimize the overall timeline, shorten the project duration where possible.
And of course, we can't forget the venerable Gantt chart.
The classic, still incredibly useful.
A staple for visualizing timelines, showing task durations as bars on a calendar, illustrating dependencies, and tracking progress in an easily digestible format. Everyone recognizes a Gantt chart. B. Managing the money. Plan cost management. Beyond time, money is, of course, a huge factor, always. Plan cost management is the process of defining how all project costs will be estimated, budgeted, managed, monitored, and controlled.
Got to keep a tight leash on the finances.
From concept right through to completion.
And when it comes to estimating those costs, our sources highlight something really important. Financial accuracy evolves throughout the project lifecycle. It's not static.
How do you mean?
Well, early on, when you have very little detailed information, you're working with educated guesses, what are called rough order of magnitude, ROM estimates. These can have a really wide variance. The sources say maybe negative 25% to plus 75%. That sounds huge, but it reflects the uncertainty.
So very approximate early on.
Exactly, and that's perfectly acceptable when you have minimal information. But as the project progresses and you gather more details, you finalize designs, get quotes, your estimates must sharpen, you move through budget estimates, maybe definitive estimates later in the project, which should be much more accurate, maybe negative 5% to plus 10%.
So accuracy gets tighter as you go.
Precisely. The real takeaway here isn't memorizing those specific percentages. They can vary. It's understanding that you need to be transparent about the level of accuracy at each stage, and that your decision-making should be guided by estimates that become increasingly confident as more information becomes available. It's like focusing a camera lens fuzzy at first, but should get crystal clear by the end. C. Ensuring excellence. Plan quality management.
Next up, quality. Can't forget quality. Plan quality management is all about identifying the specific quality requirements and standards for the project and its deliverables.
What does good look like for this project?
Exactly. And then documenting exactly how the project will demonstrate compliance with those standards. It provides the guidance on how quality will be actively managed throughout the entire project, not just checked at the end.
And the sources make an interesting distinction here.
Yeah, here's a subtle but important distinction. Quality versus grade. It's not just about is it good, but is it the right kind of good for this specific requirement?
Precisely. Quality is the degree to which a set of inherent characteristics fulfills the requirements. Is it defect-free? Is it durable? Does it meet the specified performance standard?
Okay.
Grade, on the other hand, is a category assigned to deliverables that might have the same basic function, but different technical characteristics or levels of features, maybe luxury.
Like different models of a car.
Perfect example. A basic economy car and a luxury sedan both fulfill the function of transportation, but they are of different grades. Both can be high quality for their specific grade, meaning they meet the requirements and standards expected of that particular category. No defects, reliable.
So low grade doesn't necessarily mean low quality.
Exactly. A low-grade product can be high quality if it perfectly meets its specified requirements without defects. The key is aligning the chosen grade with stakeholder expectations and the project budget, and then ensuring the highest possible quality within that chosen grade.
And our sources give us some clear, practical guidance on how to achieve effective quality management. First, it will always cost more if the customer finds any defect later on. Rework, warranty claims, reputation damage.
Prevention is cheaper than cure.
So, the ultimate goal is to prevent defects from reaching the customers in the first place. Build it right the first time.
Absolutely.
Second, build quality into the planning and design of a project right from the very beginning. Don't try to just inspect quality in at the end. Design it in, engineer it in, plan for it up front.
Proactive, not reactive.
And third, foster a robust culture of quality throughout the entire project team, where everyone feels responsible for the end product, not just the quality control department.
Quality is everyone's job. D, leveraging resources. Plan resource management. Finally, to bring all this planning for time, cost, and quality to life, you absolutely need resources. People, equipment, materials.
Can't do anything without them.
Plan resource management is the process that describes how to estimate, acquire, manage, and utilize all your tangible and physical resources effectively. We often think of this in terms of the 3 M's, or maybe 4 sometimes. Man, your personnel, the team, materials, all the supplies and components,
Yeah.
and machines, the equipment needed to do the work. Sometimes method is included too.
Right.
It's about ensuring you have the right resources, the right people with the right skills, the right materials, the right equipment available at the right time in the right place to execute the work efficiently and effectively according to the plan. 6, people and process, stakeholders, teams, and documents.
So we've talked about the what, the when, the how much, and the how well. But projects aren't built in a vacuum, are they?
Definitely not. They're intensely human endeavors.
They involve people, lots of them, and a mountain of communication and documentation to keep everyone aligned. Let's dive into the human element and the crucial paper trail or digital trail these days that makes it all work. A, engaging everyone. Project stakeholder management.
One of the most critical aspects, especially right back in the initiation phase, but really throughout the project, is project stakeholder management.
Managing all the interested parties.
Yes, this involves starting with a well-defined scope statement, but also the early identification of all project stakeholders, anyone affected by or who can affect the project, and ensuring that adequate resources are available to manage those relationships. It's about getting everyone on the same page, or at least understanding their perspectives right from the get-go.
And when we say stakeholders, we mean potentially a very broad group of people, right?
Right.
Our sources give us a comprehensive list, including customers, obviously,
Hmm?
governments or regulatory bodies, partners you might be working with, internal finance teams, support staff who might inherit the project output, sales and marketing teams, and of course, the owner or sponsor who's paying for it.
It can be a very long list on complex projects. Identifying these stakeholders early is absolutely crucial for setting realistic expectations and ensuring buy-in.
Why is early identification so important?
Because mismanaging stakeholder expectations or failing to involve key parties early on can derail a project faster than almost anything else. Someone pops up late in the game with a major objection or requirement you didn't know about. Disaster.
Right.
It's about building a coalition of support, understanding diverse needs and potential conflicts, and proactively communicating and addressing concerns before they escalate into major problems. It's a proactive approach to managing the human side, the political side sometimes, of the project. B, defining roles. The responsibility matrix, RACI.
With all those people involved, clarity of roles is paramount. Who does what?
Absolutely critical. Avoids chaos.
That's where a responsibility matrix,
Mhm.
often called a RACI matrix, comes in. This is a simple yet incredibly powerful graphical presentation, usually a chart mapping critical project tasks against team members.
Showing who's on the hook for what.
Exactly. It defines the precise level of responsibility or accountability for each person on key tasks. It's designed to avoid confusion and prevent that frustrating feeling of going in circles because no one knows who's supposed to actually do something or who makes the final decision. It cuts through ambiguity.
And this raises an important question. Without a clear RACI matrix, how easily can vital tasks fall through the cracks because everyone thought someone else was doing it? Or critical decisions get delayed because no one knows who has the authority?
Yeah, happens all the time.
It's a simple tool, but immensely powerful for clear communication and accountability. Let's quickly break down what each letter in RACI stands for. R is for responsible. This is the individual or individuals assigned to actually perform the work or task, the doer. There can be multiple R's for a task.
Okay.
A is for accountable. This is the person who has the ultimate ownership for the completion and quality of the task and who makes the final decisions. Crucially, there should ideally only be one A per task to avoid confusion and ensure clear leadership. The buck stops here.
One boss for each task.
Pretty much. C is for consulted. This is someone whose input or expertise is required before a decision or action is taken. They need to be asked for their opinion, but they don't have the final say. And I is for informed. This is someone who needs to be kept in the loop after a decision or action has been taken. They need to know the outcome, but they don't need to be involved in the doing or deciding, just kept up to date.
That clarity is priceless. It ensures everyone knows their role, what's expected of them, and who they need to go to for decisions or information. Avoids stepping on toes. Avoids things getting dropped. C, the paper trail. Project documents. Now let's talk about the absolute mountain of paperwork or perhaps digital files nowadays involved in any significant project. These are project documents.
The evidence trail.
Exactly. They're essentially the evidence of every single transaction, decision, and piece of information that directly or indirectly impacts the project goals. They are a meticulously kept record of everything: agreements, contracts, requests for information, instructions given, site condition reports, records of completed work, meeting minutes, and so much more.
If it wasn't written down, did it really happen? In project management, often the answer is no.
So what does this all mean? In a nutshell, document everything. It's not just bureaucracy for the sake of it. It's your project's history book, it's your communication tool, your roadmap, and importantly, your legal shield.
Hmm.
Our sources give us several compelling reasons why these documents are so utterly important. First, projects are now far too complicated to rely on memory or verbal agreements alone. Too much detail, too many people.
Human memory is fallible.
Second, they take a significant amount of time, sometimes years. Detailed, consistent records are absolutely essential for continuity over that time. Third, projects often go through several managers, contractors, and supervisors over their lifespan. You need a consistent, accessible record that transcends individual personnel changes.
The project knowledge shouldn't walk out the door when someone leaves.
Fourth, in today's world, simply shaking hands on an agreement is no longer enough, especially for significant commitments. Formal documentation is a must, and critically, these documents provide the necessary legal cover. They protect project teams, companies, and individual careers from disputes, claims, or liabilities down the road.
It's your proof. The relationships between these various documents are also highly structured. We generally have engineering documents, which are primarily design-oriented, think blueprints, technical specifications, calculation sheets, that how to build it docs. Contractual documents, which are relationship-oriented, the agreements, the terms and conditions, payment schedules, the legal framework between parties, and monitoring documents, which are progress-oriented status reports, performance measurements, risk registers, issue logs, tracking how things are going.
So different types for different needs.
Exactly. Each type serves a distinct purpose, but they all interconnect to form a comprehensive, auditable record of the entire project journey.
And to manage this potential flood of information, document control is absolutely essential, isn't it?
Oh, vital. Otherwise, you drown in paper or lose critical files. Document control is the systematic generation, review, approval, distribution, storage, and retrieval of all project records.
Making sure the right info gets to the right people at the right time.
And that they're using the latest version. Basic elements of good document control include things like a clear document title, a unique reference number, the date it was created or revised, who was responsible, who received it, signatures for authentication where needed, proper pagination so pages don't get lost, and crucial version control.
Version control seems huge. Using an old drawing could be disastrous.
Absolutely disastrous. Good document control does several key things. It establishes clear sources and recipients, who sent what to whom, provides a chronological record of events, what happened when, helps ensure updated versions are always distributed and used, and very practically helps you organize your files efficiently. So crucial information is always findable when you need it.
And all these documents aren't static. They flow between people and organizations, right?
Constantly. Document flow refers to the structured process by which documents are developed and migrated from one project party to another. This can happen at several levels within the project team itself, or between different departments within a company, or between the owner, designer, and contractor.
And how that flow works depends on how the project is set up.
Exactly. It varies significantly based on the specific project delivery methods chosen, which we'll touch on next. It's a dynamic ecosystem of information exchange that keeps the project moving forward, but it needs to be managed. 7. The bigger picture. Construction industry specifics.
Now let's zoom out a bit and look specifically at the construction industry. It's a behemoth, responsible for building our physical world, and it involves incredibly complex projects.
Absolutely. Huge investments, lots of risk, many players.
It has its own unique frameworks and challenges, even while rigidly adhering to the core project management principles we've discussed. A. The construction project frameworks, a phased approach.
The typical construction project lifecycle has distinct phases that mirror our earlier discussion of initiation, planning, etc., but often with industry-specific names and activities. It often starts with a feasibility study. Here, the owner gives initial approval to explore an idea. A thorough study is conducted to assess the project's viability, market, technical, financial, and then the project is officially initiated once feasibility is confirmed. Can we even do this? Should we do this?
So even more emphasis on that initial gotta go.
Definitely, given the scale of investment. Next is detailed design. This is where detailed requirements are defined, comprehensive architectural and engineering designs are prepared by the design team, the owner reviews and approves these designs, and then the full suite of construction documents, blueprints, specifications, etc. are developed, the how to build it package.
Got it. The blueprints.
After the design is locked in, or mostly locked in, we move to pre-construction. This phase involves selecting a contractor, often through a competitive bidding process. Potential contractors are formally invited to bid. A designated bid period allows them to prepare their detailed proposals and pricing, and comprehensive bid packages containing all the project details and documents are provided to them.
The bidding stage.
Exactly. Finally, we reach construction, often including turnover commissioning. This is where authorization is given to the selected contractor to begin the physical work. The actual building phase takes place on site. The completed project is then formally handed over to the owner in the turnover and closeout stage, punch lists, warranties, final payments, and the owner formally accepts the completed project.
So a very structured progression.
Yes. This framework ensures a methodical progression from initial concept to final completion, ideally minimizing surprises along the way. Those surprises still happen. B. Construction components. Engineering versus management.
Within all this construction activity, it's important to distinguish between two core, equally vital components, isn't it? Engineering and management.
Yes, they are distinct but inseparable for success.
Engineering, as our sources put it, has to do with the application of scientific methods to materials to assemble parts of the whole. It's the technical expertise, the physics, the material science, the how of building something soundly and safely.
The technical design and execution.
And management has to do with ensuring that all the resources, people, money, materials, time required to effect that assembly are available and in order. It's the orchestration, the planning, the coordination, the guiding hand.
Making sure the engineering can actually happen effectively.
Both are absolutely necessary to complete a project successfully. You can have brilliant engineering designs, but if the management of resources, schedule, budget, and risk is lacking, the project will struggle or fail.
Absolutely, and conversely, perfect management can't compensate for fundamentally flawed engineering or design. They are two interdependent sides of the same very important coin. You need both technical competence and managerial skill. C. The 5 M's of construction.
Here's where it gets really interesting. Our sources introduce us to the 5 M's of construction, offering a simple but profound way to categorize the key influences on a construction project.
The 5 M's, yes.
MAM, referring to personnel, the human resources, the skills, the labor.
Yeah.
Materials, all the physical components, concrete, steel, pipes, wires.
Yeah.
Machine, the equipment needed, cranes, excavators, tools. Methods, the processes, techniques, and procedures used to do the work.
Right.
And Mother Nature, environmental factors, weather, ground conditions, etc.
It's a handy checklist of resource categories.
But the profound implication here, the sources point out, is that among these 5 parameters, only one, Mother Nature, is truly beyond our direct control.
Interesting point.
We could exert a reasonable level of influence, plan for, and manage man, materials, machines, and methods to achieve desired project outcomes.
We can choose the people, buy the materials, select the equipment, define the processes.
It truly highlights the human element of preparation and foresight. But it also poses a challenging question to us. Are we adequately prepared for the uncontrollable M-HEM? What level of resilience have we built into our plans to deal with unforeseen weather events or unexpected site conditions?
That question really encourages critical thinking about risk management. While we can't control Mother Nature, effective risk management in construction heavily involves planning for the potential impacts of weather, geological events, and other environmental factors.
So contingency planning.
Exactly. It ties directly back to building resilience into our project plans, understanding that while we can't stop a hurricane, we can absolutely prepare for its potential arrival, design structures to withstand likely forces, and have plans in place to mitigate its consequences. It's about being proactive in the face of the inevitable uncertainties. D. The 3D concept in project management.
Our sources also introduce something called the 3D concept in project management, which provides another useful lens, another way to categorize key project elements. What's that about?
It seems to group key considerations into 3D categories, though maybe with an A thrown in for assistance. Let's see. First, assistance, which refers to key leadership and support roles like the project manager, the construction manager, perhaps a full-time construction supervisor on site who provide essential guidance and leadership.
The key people driving it.
Second, cost and finance, which encompasses all those crucial aspects like managing the project finances, ensuring its economic viability, controlling the schedule, which impacts cost, and maintaining quality standards, which also impacts cost and value. Third, decision and design. This starts with the foundational decision to build phase, considering the project's purpose, why are we doing this, the overall cost envelope, the location, followed by the design concept development, focusing on function, aesthetics, long-term maintenance implications.
The what and why.
And finally, delivery, which encompasses the entire delivery system, specifically identifying and managing the flow of materials and equipment needed for project completion, getting the stuff there.
So it's another way to slice the pie, highlighting these core drivers.
Yes, it emphasizes the interconnected nature of leadership, financial control, decision-making, design quality, and logistical execution for project success. E, the project success map, a holistic view. If we connect this to the bigger picture, the project success map presented in our sources isn't just another list. It's a powerful visual metaphor for the incredible complexity and interconnectedness of everything we've discussed.
A map to success. Sounds good.
Well, it visually groups key factors. It truly encourages critical thinking about how each piece affects the whole. It maps out key elements across various crucial domains. For time, it emphasizes tools and techniques like Gantt charts for visual scheduling, having a base schedule for baseline planning, using S-curves for tracking cumulative progress, cost, or work over time, and employing network analysis like PDM for understanding task dependencies and the critical path.
The tools for managing the clock.
Under scope cost, it includes essential skills like interpreting drawings, DWG interp, doing meticulous quantity surveys to determine material needs accurately, understanding line rents, which in construction often refer to the costs associated with renting specialized equipment or perhaps specific linear elements like pipelines using the work breakdown structure, WBS we discussed, applying precise unit pricing for cost estimation, and robust cash flow management to keep the project financially healthy.
Managing the what and the how much.
Then, a whole array of project execution factors are listed, showing the vast range of operational and administrative aspects you need to manage, using logic diagrams for workflow, ensuring transparency and adherence to technical specifications, having strict quality control and material handling protocols, managing storage efficiently, running effective bidding processes, carefully selecting and managing subcontractors, handling administrative management and adhering to company policy, providing necessary training, enforcing stringent safety measures, conducting thorough inspections, performing testing and ensuring acceptance criteria are met, maintaining meticulous document control, taking accurate site measurements, and other miscellaneous but important factors.
Wow, that's a lot. It really shows everything involved.
Exactly. What this map really drives home is that project success isn't just dependent on mastering one or two individual elements, like just being good at scheduling or just good at cost control.
It's the whole picture.
It's about the effective integration and management of all these interconnected factors. Each piece contributes to the overall puzzle. It's a truly holistic view of project delivery, demonstrating that every detail from safety policy to document control to unit pricing has a place in the larger picture of achieving success. F construction in the Philippines specific context.
To bring this into a specific real-world context, our sources also provide some information about the construction industry in the Philippines. This helps illustrate how these general project management principles are applied and regulated locally.
Right, context matters. The legal framework includes specific laws like RA 544, which is the civil engineering law in the Philippines. It governs the practice of civil engineering in the country. There might be other laws mentioned, like House bills related to toll discounts or youth policies, but those seem less central to the core principles of construction management itself.
Okay, so specific engineering laws. What about the industry oversight?
Crucial to construction management are the various regulatory bodies. In the Philippines, these are implementing boards operating under a central authority called the Construction Industry Authority of the Philippines, or CIAP.
CIAP.
CIAP is the main body responsible for the overall regulation and development of the construction industry there. Understanding these specialized bodies is useful, even if you're not in the Philippines, because it highlights the kind of regulatory complexity you often find in large, vital industries globally.
So what do these boards under CIAP actually do?
Well, CIAP exercises authority over several key implementing agencies or boards, each with a specific focus. For instance, there's the Philippine Contractors Accreditation Board, PCAB. They handle the licensing and accreditation of contractors, setting standards, imposing penalties, registering them, and classifying them based on their capabilities, basically ensuring contractors are qualified.
Quality control for contractors.
Then there's the Philippine Overseas Construction Board, POCB. Their focus is on Filipino contractors working internationally, registering them, promoting their services in overseas markets, maybe offering incentives. You also have the Philippine Domestic Construction Board, PDCB. They deal with policy formulation for the local industry, monitoring and evaluating projects, handling dispute adjudications specifically for government contracts, running a constructor's performance evaluation system, CPES, to rate contractor performance, and they developed CIAP Document 102, which provides uniform general conditions for private construction contracts.
Setting the rules of the game locally.
And finally, there's the Construction Industry Arbitration Commission, CISC. They specialize in the voluntary arbitration of construction disputes for both government and private contracts. They provide an alternative to going through the regular courts, which can be faster and handled by industry experts. They also formulate policies related to arbitration in construction.
So a whole ecosystem of regulation and support.
Exactly. Collectively, these boards under CIIP aim to ensure a structured, regulated, and ethical environment for the industry, fostering growth, maintaining standards, and providing mechanisms for resolving issues. 8. Different paths to completion. Project delivery methods.
Now that we've explored the vast landscape of project management and the construction industry, let's look at how projects are actually structured and delivered. Because there isn't just one way to do it, is there?
Not at all. Different organizational structures and contractual relationships define distinct project delivery methods, each with its own set of pros and cons, advantages and challenges.
Let's start with the most common one, the one people probably think of first. A traditional project structure. Design, bid, build.
Right. The most common and often considered traditional approach is design, bid, build, often abbreviated as DBB.
How did that work?
In this structure, the owner first hires a designer, an architect, or engineer. The designer, possibly with help from specialist consultants like structural or mechanical engineers, creates the final designs, the specifications, and the bid and contract documents.
So design comes first, completely.
Typically, yes. These documents are then put out for competitive bid, and the owner selects a contractor, usually based on the lowest responsible bid. The owner then contracts directly with that contractor. The contractor, in turn, hires and manages various subcontractors and suppliers to do the actual work and ultimately provides the completed project back to the owner.
Okay, so distinct steps, design, then bid, then build.
Exactly. The key characteristic here is that there are separate contracts for design and construction. This means the owner manages two primary contracts, one with the designer and one with the contractor. The design is essentially completed and finalized before construction even begins.
What's the advantage of that?
It allows for a clearer, more defined scope at the bidding stage, which can be good for cost certainty early on. Everyone bids on the same complete set of drawings. The roles are very distinct. B, design, build, construction.
Okay, what's another common way? I've heard of design, build.
Yes, design, build, DB, has become very popular. This approach simplifies things considerably for the owner.
How so?
Here, the owner contracts with a single entity, the design-build firm, which takes responsibility for both the design and the construction of the project. One contract covers everything.
One throat to choke, as they say.
That's the perhaps cynical way to put it. This design-build firm then either has in-house designers or hires design consultants, and they also hire and manage all the subcontractors and suppliers needed for construction.
So the owner deals with just one company.
Exactly. The key characteristic is that the owner has a single point of contact and responsibility for the entire project. This streamlines communication, simplifies contract administration, and often accelerates the project timeline because design and construction phases can overlap more easily, sometimes called fast-tracking, rather than being strictly sequential like in DBB. It's marketed as a one-stop shop model. See construction management contract.
Okay, interesting. What else is out there? Our sources mention construction management contracts.
Right. Construction management, or CM, comes in a couple of flavors, but a common one is often called CM agency, or CM advisor. In this scenario, the owner remains central, providing all the overall direction and holding the main contracts.
So the owner's more involved.
Potentially, yes. The owner separately contracts with a designer, who may use specialist consultants. And the owner also contracts directly with a construction manager. The CM acts primarily as an agent or advisor to the owner, providing professional expertise in management, oversight, coordination, scheduling, cost control, etc., during both design and construction phases.
Does the CM hire the builders?
In the CM agency model, often not directly. The CM provides management services and expertise, but the owner typically holds the direct contracts with the various trade contractors or subcontractors and suppliers based on scopes of work and bid prices often developed or managed by the CM. The CM coordinates these trade contractors on behalf of the owner.
So the CM is like the owner's expert representative.
Precisely. They bring construction expertise to the owner's team early on, often during the design phase, to help optimize constructability and cost. There's another model called CM at risk, CMAR, which is a bit different, closer to a general contractor role, but the core idea of CM is bringing management expertise on board early.
It sounds like the choice of delivery method really changes how the whole project feels and operates.
Oh, absolutely. What's fascinating here is how the choice of delivery method fundamentally changes the flow of information, the lines of communication, the allocation of responsibility, and importantly, the distribution of risk between the owner, designer, and builder.
So it's a big strategic decision up front.
It is. It's not just about who does what, but how they interact contractually and operationally. This directly impacts project efficiency, potential for conflict, risk exposure, and the level of complexity the owner has to manage directly. Each method, DB, DB, CM, has its own advantages depending on the project's specific needs. Is speed crucial? Is cost certainty paramount? The owner's desired level of control, expertise, and their appetite for risk. It's a strategic decision that shapes the entire project journey right from the start. Intra-project document flow examples.
And regardless of which method you choose, the daily reality of managing the project involves that constant, intricate exchange of specific documents we mentioned earlier.
The lifeblood of the project, keeping things moving.
Our sources provide some excellent examples of this intra-project document flow, showing how information moves back and forth between the parties. A request for information, RFI. This is typically when a contractor or subcontractor encounters something unclear or missing in the drawings or specifications and formally asks the designer for clarification.
Very common, happens all the time.
Design revisions. If the designer needs to make a change to the approved plans, they issue formal revision documents to ensure everyone is working from the updated information. Linked to change control.
Critical for avoiding errors.
Contractor shop drawings. These aren't design drawings, they're detailed drawings prepared by the contractor, a sub, or supplier, showing exactly how they intend to fabricate or install a specific component, like steel beams or ductwork. The designer usually reviews and approves these before fabrication.
Checking conformance with the design intent.
Billings requests for payment. The contractor submits periodic requests for payment based on work completed, often supported by documentation, and record of meeting minutes. Formally documenting decisions made, actions assigned, and key discussions from project meetings, site meetings, coordination meetings to ensure everyone has a shared understanding and record.
Essential for accountability and avoiding he said, she said.
These aren't just pieces of paper or digital files. They are the mechanisms for communication, clarification, confirmation, and accountability within any project structure. Managing this flow effectively is key. Outro. Wow, what a deep dive. We've really journeyed from the very essence of what makes a project, that temporary, unique endeavor, all the way to the intricate dance of stakeholders, schedules, budgets, quality, and even the specific laws governing an entire industry like construction.
It's a huge field.
You really get a sense of the immense planning, coordination, and frankly, discipline required to bring these complex undertakings to life. From defining the core characteristics of a project through its 5 key phases, to the detailed toolkit of process groups and knowledge areas, we've seen how crucial that structured thinking is.
Structure brings order.
We've explored the unforgiving triple constraint of scope, time, and cost, and adding quality to that mix. We unpacked the importance of a robust work breakdown structure for defining the what, and we stressed the critical role of documentation, clear communication, and choosing the right delivery method in every single phase.
Indeed. This deep dive has hopefully shown us that whether you're literally building a house or maybe launching a new software product or organizing a major event, understanding these fundamentals, the WBS, the triple constraint, the importance of stakeholder management and clear documentation, the different ways to structure delivery is your shortcut to being truly well-informed.
And hopefully more effective.
And critically more effective. It's about proactive planning, anticipating challenges rather than just reacting to them, and having a systematic approach to navigate the inherent complexity. Knowing these frameworks allows you to see both the forest, the overall goal, and the trees, the individual tasks and risks. It helps connect the minute details to the overarching vision for success.
So as you go about your day, maybe dealing with your own projects, big or small, think about this. Our sources highlighted the 5 M's of construction and suggested that only Mother Nature is truly uncontrollable. What uncontrollable factors exist in your own projects, whether professional or personal? And armed with all these tools and insights, we've discussed the planning techniques, the risk awareness, the communication strategies. How prepared are you, really, to understand and mitigate their potential impact?